Good afternoon, students. Today we are going to start a new lecture series on a course Signals and Systems. As the title of the course involves two concepts, signals and system, here also we are going to discuss about both signals and system in all the units. Myself, Dr.A.Vaniprabha, Associate Professor, EC Department, working in SNS College of Engineering. Welcome you all for this new course series, Signals and Systems. Okay. From the basic level, let us understand what a signal is. And we always used to say that the signal is very bad, it is poor, it is not reachable. All these words we are familiar with. Actually, what a signal is. To properly define, a signal is nothing but a representation of a physical phenomena that is happening for a particular task. For example, I am speaking now, my voice shall be referred as a voice signal which consists of both amplitude and frequency. So this any kind of representation of a signal that naturally happens around us can be termed as a signal. And what a system is? It is nothing but entity or a block that manipulates or that works on the given signal, whether the signal may be a one signal or multiple signals, so as to uh, get back a original or desired function. That is known as a system. Okay. So the signal may be a function of one or more variables. Means, let us say, the temperature of a room. It varies with respect to time. Morning will be having a different temperature, like 28. In the mid noon, we will be having some 32, or in the evening, some other temperature range. So a signal is dependent on a one variable, which is nothing but the time. The temperature is dependent on time. Whereas the moving of a car may depend, that is the speed of the car may depend on the nature of the road and also the acceleration, right? So in this case a signal can be classified as a single variable or more variables, right? For example, it may be voltage with respect to time, current with respect to time, or temperature with respect to time, humidity, or illumination, all these with respect to time. One dimensional signals or multi-dimensional signal is named as a signal that depends on only one parameter or one factor is one dimensional signal, or a signal that depends on two or more parameters, it is named as multi-dimensional signal. A system, from the block diagram you can understand a system is a functional circuit or maybe a small circuit that operates on the given input signal and gives the desired output signal. For example, the system may be a filter or an amplifier or a rectifier, whatever it is. So some commonly named systems are communication systems or speaker or amplifier system and aircraft landing system. Everywhere, wherever we have some reference or a control elements, there we will be having a system so as to monitor the reference or threshold level and to control the linked circuits. Classification of signals. Classification of signals are many based on the dimension. It is classified as single dimension or multi-dimension based on the variable, that is whether it is continuous time or a discrete time. Continuous time signal means the name implies the signal is continuous in nature. The first drawing depicts the continuous time signal. Here there is no breaks or interferences in the signal. It is smooth curve. It is continuous in nature along with respect to the time. Whereas discrete signals or discrete time signal, it is not continuous. uh, we'll be having the values of the amplitude at periodic intervals for every 2 second or every 3 second, or at particular time intervals the signal samples are taken and it has been given here. You can see the graph like horizontal lines over the vertical lines are marked. That is the samples taken from the continuous time signals. These are the samples which is taken at periodic intervals of time. It is not a smooth curve. So how this discrete time signals can be obtained? It can be obtained by sampling the continuous time signal x of t, whereas discrete time signal is represented as x of n. N stands for discrete time, t stands for continuous time. Therefore, this n can be obtained by sampling the t. It is nothing but xn of t, where n is nothing but 0 integers, 0, 1, 2, 3, 4. And what is the main requirement for sampling? We have already studied in lower classes sampling. Sampling is nothing but taking samples at regular time intervals from a given continuous input. The sampling is just like that. We can't take samples or sampling the signals. It has some threshold value. That is, the sampling frequency must be 2 times greater than the maximum frequency. That is the Nyquist criteria. He stated the threshold that the sampling frequency must be greater than or equal to the twice the time of the maximum frequency of the signal which is under consideration. Right. He has fixed the threshold level of the sampling as Fs, and it is or it must be greater than or equal to twice the times of maximum frequency of the signal which has been considered for sampling purposes. And next type of signal is even and odd signals. Even signals and odd signals are mathematically represented as x of minus t and x of which is equal to x of t. If x of minus t is equal to x of t or x of minus n is equal to x of n, then that signal can be classified as even signal. Vice versa, x of t x of minus t is equal to minus x of t or x of minus n is equal to minus x of n, then it is called as odd signal. How to understand this x of t and x of minus t? This minus t represents the negative axis, negative part of the time axis, whereas plus t represents the positive positive side of the t axis. See, here we can see this drawing. You can see the bisection on the horizontal line, right? The left portion indicates the minus t and the right portion indicates the positive time. So whenever we are shifting or reversing the signal, if this x of t is equal to x of minus t, then it is even signal. X of minus t literally means this is the reflection or mirror image or like that. While working the problem on this, you can have a better understanding. Okay, any signal can be expressed in terms of even and odd component. How we can represent a signal as even and odd? X of t, consider x of t as a signal. This can be decomposed into even and odd signal, which is equal to x e of t plus x o of t. And the mirror of that given x of t is x of minus t, which is nothing but x e of t minus x o of t. Whereas x e of t can be written as x of t plus x of minus t divided by 2, and x of t can be written as x of t minus x of minus t divided by 2. As we factorize or simplify in regular numerical analysis, here also any signal can be decomposed as both even component and odd component. Hope you understood this session. Thank you for listening. We'll discuss the next topic in the upcoming lecture series. Thank you for your listening, students. Thank you.